1.
Hey guys, talking about prime factorization. Before we can move into prime factorization, we have to have a little background knowledge about prime and composite. So a prime number is a number that has only two factors. An example would be 2 because the only way we can get 2 is to multiply 1 times 2. Or another example would be 3 because you can only multiply 1 times 3, and 5 because you can only multiply 1 times 5 in order to get 5. Our other type of number is composite, and a composite number is a number that has more than two factors. An example would be 4 because you can multiply 1 times 4 or 2 times 2. 10 and 15 are also other examples of composite numbers. So as we look at prime factorization, we are going to we're going to make prime factorization with factor trees. So we're going to take our first number, 32, and we are going to create a factor tree for that. Now, whenever we're doing prime factorization, we typically make factor trees using composite numbers. So 32 is a composite number because it has more than two factors. As we build our factor tree, we're going to think of two numbers that I can multiply together to get 32. Now, there's multiple ways that we can come up with 32. Just use whichever two factors that you think of first. With 32, I typically think of 4 and 8. Now, whenever I get my two factors, I want to look and see, are either one of those factors prime? Neither one of those factors are prime because they can still be broken down again. So I can't circle them. So I'm going to break down my 4. And my 2 factors are 2 and 2. Now, as I look at that 2 and this 2, I know that 2 is a prime number. So I'm going to circle those numbers. Next, I'm going back to my 8 because it's not circled yet. It was not a prime number. And I'm going to see how can I break 8 down. Well, 8 can be broken down into 2 to 2 and 4. And 2 is prime, so I'm going to circle it. And 4 is not prime. I've got to break it down. And I can break it down into 2 times 2. Now, when I look at all of the numbers that I have remaining, I have 2 times 2. Notice I'm checking them off. One of the reasons that I do that is so that I don't forget any of the numbers that I have circled. And now I have that prime factorization written in expanded form. And now I'm going to write it in exponential form. My base is 2, and I have 1, 2, 3, 4, 5 of them. So my prime factorization is 2 to the 5th power. If I were to go back and multiply 2 times 2 times 2 times 2 times 2, it would give me 32, the number that I started with. That's the point of these factor trees, is to break it down into products of primes. My next example is 70. So when I see 70, of course, I know it's a composite number. And one of the ways that we start to kind of think, okay, is this a composite number? Is it an even number? If it's an even number, you know that it is going to be a composite number because 2 is a factor of it. The only exception to that is the whole number 2. So I'm going to break down 70. And when I think of 70, I think of 7 and 10. So I'm going to circle 7 because it is a prime number. The only way I can get 7 is to multiply 1 times 7. Now I have 10, and that can be broken down into 2 times 5. Those are the factors of 10. So I'm going to circle 2. I'm going to circle 5 because all of those are prime. And now I'm going to write them. Oops, sorry about that. I'm going to write it in expanded form. I have 2 times 5 times 10. And on this problem, the expanded notation and the exponential would be exactly the same. Since there's no repeats, I'm going to leave it just like this, 2 times 5 times 10. Okay, let's take a look at one more. This time we're going to take a look at the number 40. We're going to break down 40 because it's composite. I'm going to break it down into 2 times 20. That may not have been the way that you initially saw it, but guys, any way that you break it down, you're going to end up with the exact same prime factorization. So when I have 2 and 20, I'm going to circle 2 because it's prime. 20 can be broken down again into 2 and 10. Circle my 2 because 2 is prime. And now I have 10, which can be broken down into 2 times 5. And I'm going to circle each one of those because they are prime. I couldn't circle the 20 because it wasn't prime. It could have been broken down. And I couldn't circle the 10 because it wasn't prime. So now I'm going to write this in expanded form. I have 2 times 2 times 2 times 5. That's my expanded notation. And as I write it in exponential, I have a base of 2, and that occurs 3 times. 2 times 2 times 2, so it's written as 2 to the third power times 5. Hope this lesson on prime factorization helped. Have a great day.